Hello everyone, let's try and solve question 7 from TUT 3 because I think it was quite a challenging question and it might be helpful for you to have a video to see how I would do something like this. So this is just my interpretation of how I would attempt to solve this big problem, this big calculation of mass fractions and so on. And there's not just one way, there's probably many ways to do this, but keep in mind that TUT 3 was all about for loops, and so we want to try build a solution where we're actually using for loops. So with that, I'm going to minimize this and open up MATLAB. So I've already opened up MATLAB, and now what I want to do is I want to first create a script that's going to store my solution. So I'm going to do what we normally do and say new script, and then I'm going to just save it as let's call it question 7 answer. Question 7 answer. Then we're going to save it, and now we've got our script where we're going to write all of our code. So with that, let's go back to the question. There were a few hints regarding how we could maybe start solving this problem. So the first was start off by creating two vectors, right? M and N that hold the information for species molar mass. So this column over here, or this column over here, sorry, column 1, and molar flow rate, column 2, respectively. Then write a for loop that loops through each element and calculates the required information for each row in the table. So just to clarify how we would find the mass flow rate of component I in a stream is we would say, well, let's take component 5. If I wanted to find the mass flow rate of component 5 in my stream, then if I have the molar mass, the molecular weight of component 5, which is 78, and I have the molar flow rate, which is 17, then I could just multiply those two numbers together, and then I would get that number over there. If I wanted to do row 17, which corresponds to component 17, then it would be 201 times 38. If I wanted 31, it would be 94 times 12, and so on. And so what I'm trying to get at is we need to find a way to loop through each row in this table and multiply the corresponding elements in the other columns together to give us the mass flow rate. So the first thing that I want to do is actually make these columns. I want to make these columns in MATLAB so that I can access the information. And I made it a bit easier by giving an Excel spreadsheet that had all of the information ready. So this is Excel. I'm sure you know that already. What I want to do is I want to extract the numbers from this table and put it into MATLAB. And the way that I can do that is MATLAB is it plays nicely with Excel in that I can copy numbers from Excel and just paste it into MATLAB, and MATLAB will understand what's going on. So what I want to do is I want to make two variables, one that is a vector for the molar mass and another vector that represents the molar flow rate. So let's make the molar mass a variable. So what I'm going to do is I'm going to highlight all of the molecular weights for all 50 component streams. Oops. Okay. And once I've highlighted it, I can right click and then say copy. Now I can go back into MATLAB and let's start writing our code. So I want to have M. The hint was let me make a variable called M, and it's going to be a vector. So vectors are just matrices in MATLAB, and that means I must make them with square brackets. Let me put a semicolon at the end to stop it all printing out to the screen. And now that I've copied the numbers from Excel, all I can do is right click and then I say paste. And when I do that, MATLAB and Excel talk to each other and they give me the column that I copied from Excel and I put it into MATLAB. So if you see a 121, 147, 209 is the same as 121, 147, 209 in Excel. So I've copied this column into MATLAB. So let's now do N, the molar flow rate vector. So I'm going to write another variable, N, It's also going to be a vector, so I do another square bracket. I want to suppress the output. I don't want it to print to the screen because it's a lot of numbers. So I'm going to put a semicolon. And then I'm going to go and do the same procedure for molar flow rate. So now the column for molar flow rate is column C in Excel. So let me highlight all of these numbers. All 50 numbers I'm highlighting. Now again I'm going to right click, say copy, then go back into Excel, into MATLAB, excuse me, and say paste. And if I look now, I've got 18, 17, 23. That's the same as 18, 17, 23. So I've copied all 50 molar flow rates now into MATLAB. So let me just save this. So again, I can see that I haven't saved my file because I have a little asterisk, a little star at the top. And if I run it, it won't see all of the stuff that I've changed. So I'm going to save this first. And if I run it, looks like nothing's happened. But I've just created two variables holding the molar mass information and the molar flow rate information for our 50 component stream, and I can see that in my workspace I've created two variables, m and n. So how big are m and n? Let me check. If I just type m into the command window, then I get all of my molar masses out, and if I type n, then I get all of my molar flow rates back. So that's the first part of the solution. I'm going to stop it here just to keep the videos short. In the next videos I'm going to explain how we can use for loops to solve this problem.